small calculation for just a small system here. Okay, we have two gears that are connected with a 97% efficient chain. So the driver gear has a diameter of 2 feet and is connected to a 10 horsepower motor, turning at 2,000 RPM. The diameter of the driven gear is 5 feet. Go ahead and calculate the torque of both gears, the RPM and horsepower of the driven gear, and the linear velocity of the chain. Alright, so let's go ahead and find the torque of the driver gear first. That one's easy. We have the horsepower and the RPM. So remember that our torque, okay, is going to be horsepower times 63,025, okay, divided by RPM. So this is going to be 10 times 6325 divided by 2,000. So that's going to yield roughly 315 and some change, 1.25. Okay, and that's foot-pounds. Okay, let's go ahead and find the RPM of the driven gear. To do that, we can use the ratio. Okay, and notice this gear should be spinning faster than this gear, so we're going to take 2/5 of the original, or the starting RPM, so 2/5 times 2,000 is going to equal 800 RPM. Let's calculate the horsepower of the driven gear. So this up here, this was the torque of the driver. Okay, so we're going to do here horsepower of the driven. This one's a little easy. We have our original horsepower of 10, and the chain is 97% efficient, so we lose 3%. So we can just take our original horsepower, 10 horsepower. We're going to multiply that by 0.97, which is this percentage as a decimal, and we should get 9.7 horsepower. Now that we have the horsepower and the RPM, we can calculate the torque of the driven gear here. Okay, so we're going to go torque driven. Plug into the same torque equation here, only using our values that are applied to this gear. So our horsepower is now 9.7 times, this part doesn't change, it's a constant, 63025, and we're going to divide that by our RPM now, which is 800. Okay, so when we do this calculation, we get 764.17. Okay, and that's also in foot-pounds. Okay, lastly, we want to calculate the linear velocity of the chain. Now there's two ways of doing this. Okay, you can either doing it using this portion or this portion. You just have to do it consistently. So I'll show you both. Okay. We can do, alright, well, if we look at the first system, it's going to be pi times our diameter, which is 2 feet. And that's going to be times our RPM of this system, which is 2,000. And you should get 12,566.37, and that's going to be feet per minute here. Okay? Now, if you wanted to use the alternative way, and that would be with this guy down here, this is pi times 5 times 800 RPM. Notice the 5 is the diameter of this gear, the 800 is the speed of this guy. When you do that calculation, you should get